Welcome to 5.2 AP Statistics with Mr. Sheevy. Alright, today's agenda, conditional probability and independence. That's right. I got nothing good for you. Alright, hopefully it'll go smoothly. I got the timer set for 15 minutes. I'll use the whole time up, but hopefully no more. Hopefully. Alright, so let's get crack-a-lackin'. All right. First of all, conditional probability. All right. Conditional probability is basically the thought process of given something or that we know about something. Okay. So, for instance, what's the probability of drawing a heart? Okay. Well, drawing a heart is 1/4 of a deck, right? But conditional probability would be, I'm going to tell you a condition, all right? Now, I'm going to tell you what's the probability of drawing a heart given it's red. What's the probability of drawing a heart given it's red? That's completely changed it. Basically, I'm saying, I'm holding a red card. What's the probability it's a heart? And now you can say, well, now it's changed, completely changed to 1/2 now, right? Because there's hearts and there's diamonds that are red. So that given, whatever is given, we're only focusing on that. Now, I'm going to use purple. Whew, I feel lucky today. That's how we say given. Now remember, this means and, this means or, this means given, and this means not, right? Okay, all right, just a little bit of review on knowing your symbols. So given is basically that, and let's just get our hands dirty. All right, okay. All right, so it says, consider the two-way table on page 314 in your books. Pull out your books. Just kidding, you don't need to. Define events. All right, E is the grades come from EPS course. So they come from engineering, physical science. And L is the grades lower than a B. Lower than a B. All right. So find the probability of L. Okay. So the probability of L would be lower than a B, and that would be this. So it's going to be 3656 divided by 10,000. All right, and I'm no rocket scientist, but I believe that's 0.3656. Okay, I just take the total, everything below a B, and divide it by the total. Now, here's the deal. Find E given L. All right, let's do this one in a different color. Ooh, let's go really fancy. Let's go pink. All right. So, what's the probability of E? So they came from an EPS course, given they had a grade lower than a B. So this says given they had this. So as soon as I read that given statement, I'm only focusing on what is given. I don't care about anything else. I basically make the whole world disappear except for what is given. Oh, shoot, I think I lost the pink. Oh, no, it's still there. And it's given that they have a lower than a B. So I only care about those guys, right? That's it. Everybody else, I just say, phooey on you. Phooey on you guys. I know it's got to be below a B. I know that. Now, it's saying what's the probability they were in an EPS course? So it would be 800 out of 3656. So it's going to be 800 out of 3656. Okay, and let's see what that's going to be quick. 800 divided by 3656. That is roughly 0.2188. Perfect. Finally, this last one. Let's make this, I'll be classic black. I'm a classy guy. Now, how's this going to change? All right, well, what's it going to change here? Didn't we just do this problem? Come on, didn't we just do this problem, Mr. Shigu? Why are you making me do it again? Well, this time we're given they took an EPS course. So who do I only care about? Well, I only care about these guys right here. That's all I care about. Basically, these guys and that guy and this guy, I don't care about. I don't care about those guys. I only care about the people in the engineering and physical science. And what's the probability they scored below an 800 or below a B? So I'm going to go 800 out of 16,000. Okay, and that is last I checked 50%. So if you were taking this kind of class, engineering and physical science, 50% get below a B. Now, you guys have all taken that class. I want you to just state real loud, what class is your hardest, do you think? Do you think it's easier to get below a B? Yeah, I think, in calculus, probably, right? But a B in PE, hopefully, is not too hard. Hopefully. Okay, let's move on. Otherwise, I'm going to run out of time. All right, how would we do this on a Venn diagram? All right, so here we go. What is the probability that a randomly selected resident who reads USA Today? Now, as soon as I see this, who reads USA Today, do I care about anybody else? I think I only care about the people who read USA Today. That's this group. I only care about those guys. Phooey on everybody else. It's like everything else just fades away. Also reads the New York Times. So I see, oh, well, these guys read read both papers out of, well, how much is their total in the USA Today range? Well, there's 35 and 5. So it'd be 5 out of 40. You guys see where I got 40, 35 and 5. 35 and 5 makes 40. Okay. And last I checked, I'm not going to take my chances. It's been a long day. 0.125 is my correct answer. That's how I would do it on a Venn diagram. Capiche? Capiche. All right, moving on. Okay, why don't you guys try this one out on yourself? Why don't you pause it, and then we'll see which way you prefer, Venn diagram or the other, and I will do it quick too as well. All right, so if you're like me, you might have gotten stuck right about at this point in time, okay? And I got drugs over here, I got no drugs, and then I got plus and minus, whether they got a positive or a negative result. Now here's the deal, as it says, a false positive is when you did not take drugs. So that would be these guys right here, right? They did not take drugs, however, it flagged them as druggies, right? Druggies. Okay, so that happens 1% of the time. Now remember, we only really care about the people who don't take drugs, right? That's basically people who don't take drugs, they get flagged as positives 1% of the time. So I really only care about this 980. I'm going to figure out what's 1% of this 980, and I believe 1% of that is about 9.8. Okay, and then I can start filling out the rest. Now it says 2% are false, 0.5% are false negatives, which basically means that it's these guys, right? They actually are druggies. Okay, I don't know wherever you put it. I don't know. Okay, and they don't get flagged at all. So 0.5%. So I'm going to type this in. I'm going to go 20 times 0.005. Don't forget those couple zeros. So 20 times 0.005. And I get 0.1 here. Wait, no. I'm sorry. My mistake. It would be 0.1 here. Right? Because they take drugs, so they should get a positive, but they actually get a negative, all right? And then we can fill out the rest of the chart, okay? All right. All right, so I got the chart filled out. What's the probability that an athlete who tests positive took drugs? So I only care about people who tested positive. All right, they tested positive. Those are the only people I care about. I don't care about these guys. What's the probability they tested positive but actually took drugs? Well, that would be these guys. 19.9 out of, not out of 1,000. There were only 29.7 people, right? So it's going to be 19.9 divided by 29.7. And that is about 67% of the time. 67% of the time, if you take drugs, you're going to get flagged for drugs. Okay? All right. Cool. 67. All right. Now, I only have 4 minutes to talk about independence. So, what is independence? All right. Now, a lot of people get this confused with mutually exclusive. Remember, mutually exclusive. Here's your Venn diagram. Mutually exclusive means they're not together at all, right? Okay, they share nothing in common. Independence means one does not affect the other. Doesn't mean that they don't share anything in common. It just means that one does not affect the other. So, for instance, okay, does gender depend on money? Right? We've all heard this before. Does being a female, does that mean you're going to end up getting paid less? Okay? Well, here's a scenario here, all right? So does just because of being a female, does that affect, your pay? So here's basically a breakdown I have. And basically, if I just want to see what's the probability of people who get over 70, would be this, right? So it'd be 400 out of 1,000. Okay? So about 40% of people get over $70,000, right? So we would expect that to be the same for women, right? Right? If that's the overall average, we'd expect 40% to be women. However, it might not be, right? And so how do we test to see if women have different? Well, what you do is you just take how many women are getting paid over their total, and we go 14 over 300. And this should be 40%, right? Otherwise, something's a little screwy here. And you get 0.466. Actually looks like more women are getting paid over 70. Sorry, this is actually not how I planned it. I actually thought I had it so the women got less than 40. But it does not look like these are independent of each other. It looks like gender does affect your pay. Okay, boy, I flipped that problem, huh? Because these don't line up. These are not the same. So just as a couple of scenarios, what is independent and what is not going to be independent, okay? So things with replacement, all right? So for instance, deck of cards. If I pull a card out of a deck and I leave it out, does that change the probability, depending on what I pulled out, of what the next card is going to be? And you should say, yeah, because now there's only 53 cards in a deck, not 54. Okay, so anything with replacement, if I put a card back in the deck, it doesn't change the probabilities. That would be independent. Okay, if I leave it out of the deck, it would be dependent. Now, we don't have much time to do this. Okay, I basically kind of went through the rules and probability, okay, of it all. And let's just, we'll go through one scenario. Soccer team change coaches towards the end of the season. Are their wins independent of their coach? So first of all, I would see if they're independent. I'm going to take their wins over their total, so 24 over 80. Okay, and 24 over 80 is, oh man, I only have a few seconds left. 30%. Okay, and then I'm going to take their new coach and just basically see, hey, did he actually have any effect on it? 6 over 20. Is that the same? And I'm going to go 6 divided by 20, and that's 0.3. Hey, look it. Did the new coach really help out his team? No, their winning percentage is the same. It's 30% with the new coach as it was with everybody. All right, that's how you do independency, guys. Work on whatever you can. Love you guys. Bye.